my students. Already we have covered in geometry the basic things, what is called a rectangle, what is called a triangle, what are the classifications of triangles, what are the your classifications of rectangles, like quadrilaterals. Okay, so the one more thing, like what are the things are left today, we will discuss about that. And we will move to our new chapter, and a pretty interesting chapter. I have already sent you a PDF where it's actually NCRT book that like you have to follow for the next this new chapter, which is called symmetry and patterns. And this chapter is very interesting. If you see the NCRT book, you will love it. So let us start with the things that we have left. So starting from the things, I will first talk about circle. So basically in class 4 you have a little bit learned about it, the circle. Again I am just telling you, just for a revision. A circle is a shape which doesn't have any arms. Okay, so there is no straight line in the circle. The circle is something that can be drawn from a single point from which the distance of circle is same. Like, so this is same, this much 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 is same. So any point you take on your circle, from center it will be same. So center is that point from which the distance to the like boundary of the circle is same. So this point is called your center. So this point is called your center. Okay, now the distance from center to any of the point on the circle is called your radius. Okay, acha. So basically the radius will be this much, right? But if I extend the radius, this straight line, if I extend the straight line, whatever I will get, that bigger one, like from one corner of the one point on the boundary to opposite point of the boundary, this distance is called, the total distance is called diameter. So diameter is the total distance, like this whole part is called diameter. So diameter is the total distance and radius is half of that distance. So one thing we have seen, that diameter is twice of our radius. Okay, fine. So we have learned about center, that is a point from where any the distance of any point on the boundary is same, and radius is that distance, that is the distance from center to any point on the boundary, and diameter is the twice of that radius. That means if you increase the whole radius, so that will be your diameter. Okay, now there is one more thing to tell, that is chord. So this is my center. There is something called chord, that is from one point of the boundary, if you draw any straight line to another point, it is not necessary it has to go by center, but any point like these all straight lines are called chord. CHORD, chord. But so this is also chord, this one bigger one. But if any chord passes through your center. So see, chord means from one point it has to go to another point. But if any chord passes through your center, that will be your diameter. So diameter is the biggest chord in a circle. Okay, so diameter is the largest or biggest or longest chord. Okay, so that is for circle. Now, so it was all about circle. So basically in circle, what you need to know that the radius, if you multiply the radius with 2, you will get the length of the diameter. So if I give you that my radius of a circle is 10 centimeter, so the diameter will be obviously twice of that. That means 20 centimeter. Okay, so this is it, and you know what is chord and what is other things. Now coming to our next one, that is angle. So what is angle? We know that already we have talked a little bit about it, but not exactly a lot about it. So we know that angle means if we have two lines, so how much they are close to each other, we measure that amount by angle. So if I have two situations here, so in both situations, let's say this length of the arms are same. So this is also L and this is say X. This is L and this is again X. So in both cases, the length of the arms are same, but something is different because they don't look like same. What is different? You can see that in this picture they are close to each other, means this one, like this, what you say, this portion is narrow and this portion is bigger in this picture. So something must be there to measure this closeness, right? So that's why we have angle. So angle is something that can measure how much close the two lines can be. So angle is measured like this. So this amount is called angle. So angle is created in the between, like in the intersecting point of two lines. So this is also our angle. Okay, so basically angle cannot be made without two lines. Like with one line you cannot make one angle. Achha. Now coming to the, like, how to measure angle. So basically we have something called protractor to measure angle. So if you have something like this, that is perfect L. If you have something L, so I'm trying to draw a nice L. Okay, so if you have something like L, so we called this as right angle. We call this as right angle. Generally angles are measured in degree. Okay, and like we measure length in centimeter, meter, and angle is measured in terms of degree. So this amount is called 90 degree. So right angle means 90 degree. Okay, so here there are 90 divisions, 1 2 3 4 5 6, like that. There are total, I cannot draw it here, but there are total 90 divisions. Like in clock you have seen there are 60 divisions, like 60 divisions are there. So 1 hour means 60 minutes, like that. Here in a right angle there are 90 divisions. So if you have this kind of situation, it is called right angle. If you have one more line in this side, so there we have two angles. So see, this is one angle, this is another angle. So this is also 90. So that side also it's looking like L, so it is also 90 degree. So this is also divided into 90 parts. So if you have this kind of situation, then you will be having two right angles. One is here, one is here. Okay. Now let me draw some angles and let me see, like, so this is a starting point where you have two lines very close to each other. Then you have something like this where you have like this. Then you have something like this, L. Then you have something like this, that is then you have something like this, which is, and finally you have something like this where two lines are there, but I cannot draw it nicely, so I'm just showing you the intersecting point. Okay, so the intersecting point is, say, this one. Okay, so this is intersecting point here, this is intersecting point here, this is intersecting point here, this is here, and this is here. Now the angle for this one is very less, you can see, because they are very close together. This angle a little bit higher. This is our 90 that you know already. So slowly it is increasing. This is something bigger than 90, this is much bigger than 90, and this is something. Now see, when that this arm, like this one, when this arm moves to 90 and again it is coming from this position to this position like this, so that means there is 190 and another 90 is also happening there. To make it simpler, I am telling you this, if something is like there, this is there. Okay, now this arm is increasing in this side, so slowly what will happen, first this arm will come like this and become 90 degree, right? Then again this term will go and come here, so this arm is coming down here, so how much it is covering, more 90 degree. So finally what I will get like this, so 90 and 90, so total angle will be what, my total angle will be 180 degree. Why 180? Because to become like L, this arm has to first come here, then this arm has to go down and again cover more 90 degree and then come to this side. So ultimately what you will be having, 180 degree, because 90 plus 90. Okay, so in that case what will be the angle for this case, 180 degree. So for a straight line, if you have any point and you considered this straight line as two arms, one is this one is this one, so they will be having 180 degree angle between them. So this angle will be lesser than 180, this will be lesser than 180 and greater than 90, this will be lesser than 90, this also lesser than 90, maybe it's the half. Okay, that is your 45 degree or something like that. Okay, so there are, so based on it is more than 90 or less than 90, we have three classifications. So if you have something which is, so I'm first writing your right angle, that is drawing the right angle, that is 90 degree. If you have something that is less than 90 degree, and if you have something that is bigger than 90 degree. So if you have less than 90 degree, it is called acute angle. If you have 90 degree, it is called right angle. So this is angle and this is also right angle. If you have something bigger than 90 degree, okay, so something bigger than 90 degree, degree we write like this, we give a round like this, it is equal to 90 degree and this is less than 90 degree. So this is called obtuse angle when it is bigger than 90 degree. Okay, so there are basically these three classifications: acute, right angle and obtuse angle. Now coming back to our thing, let's say you have a situation like this. You have a straight line here. You know that your right angle is in between, right? One more thing is there. Before going into this part, I want to tell you this part. Okay, how to give name of the angle. In class 4 already you have learned, but still I am revising it. So let's say you have to write the name of this angle. Let's say first I have to give some alphabet like A, B, C. Then I have to write this B. B means the intersecting point. Whatever will be your intersecting point, that means the position of your angle, that you have to write in the middle. And A and C you can write any of the sides. So A, B, C, and you have to give this symbol. That means it's an angle, because ABC can be a triangle also. If I draw a triangle and if I give name ABC and if I write ABC, that will mean that I have drawn a triangle. But how to then differentiate angle and triangle? So for that we have to give this symbol. Okay, so basically you have to write the alphabet which is the intersecting point, that means where the angle is, that you have to write in middle. Okay, and other alphabets you can write in either sides, any of the sides. Okay, coming back to our situation, let's say we have one angle, say A, this is my one point, say O, this is my B, this is my C. So I know that my angle AOB means which angle? AOB, O is middle, so AOB means this angle I'm talking about. This is equal to 90 degree, I know. Also my angle AOC, that means my this angle. See, I can draw like this also, that doesn't mean it's big, okay? Or I can draw like this also. Angle means the closeness, so how much it is inclined with each other. So in that case you can give this symbol anywhere, no problem. Whatever we are seeing AOC, that AOC is also my 90 degree, right? So this angle COB, that means which angle? I am talking about this angle, big one, is my what? The AOB plus AOC, because there are two angles in between, so it will be 90 plus 90, 180 degree. And I was talking about this only. Now let's say, so you know already COB is my 90 degree. Let's say I have a question like this. So if I have a situation like this, and I have one more line out there like this, and I tell you that this name is say A, and I tell you that this angle is 45 degree. That means this much of amount is 45 degree, and you have to find out what is this much of amount. So you have to find out A O B, but you know your A O C, that is 45. Also you know your C O P because it is 180 degree. So total you know, and 45, this much you know. So how much will be this? You have to just subtract it. So your AOB will be your 180, that is my total angle, means my total, this total angle minus my 45 degree angle. So it will come 135. That means my this angle, this much is 135 degree. So this is my acute angle, because this AOC angle is smaller than 90 and AOB is bigger than 90, so it is obtuse angle. Okay, so this kind of maths you have to do sometime. So basically this was all about angles, and I will give you one protector thing also to see whether by yourself you can measure the angles or not. Okay, so this is it. One more thing, let us do one more thing. So this is how we have to give name. And one more interesting thing, let's say I have something like this. Okay, and I have given name, this is A, O and B. So you know that this is looking like L, so this much is my 90 degree. But what is this much? So this is very interesting. So this I don't know what is this much. See, if I can imagine one thing, if I have a imaginary line here, imaginary line, then this much would be my 180 degree, because straight line is always 180 degree, right? And this line which I have imagined in my mind, and this line is making a small 90 degree. So this big is 180, this is 90. So how much will be the rest of thing? So 180 plus 90, that is how much? 270 degree. So this total part will be my 270 degree. So if this is 270 degree and this is 90 degree, so what would happen if in my next situation these two lines are coming close to each other and become like this? So this is one line and another line is almost overlapping it like this. So there is no gap, only the intersecting point is, we can see, let's say the intersecting point is this much. Okay, so now I have to find out what will be my, so inside of the two lines it is zero angle because they are with each other, right? But outside one will be how much? See, if we see the previous one, we can see the outside one I have got is 270 degree and this much is my 90 degree. So if this, so this, when this arm was moving from here to the total up to there, how much it has covered? 270 degree. And if it covers more 90 degree, so how much total it will cover? So it will cover 270 degree, that it has gone from here to this much, and from this much to that much more 90 degree, that is 360 degree. So that means in total complete revolution from here to directly up to here, how much it has to move? It has to move 360 degree. To move from here to this much only, how much it has to move? It has to move 180 degree. To move from here to this much, how much it has to move? 270 degree. So this is 180 degree, it has to move 270 degree. And finally, for a complete revolution, means from starting and ending here, we have to go 360 degree. Fine. So this is all about your angles today. So angles are a little bit, you will take some time to find out angles, and I have already told you that you have to do one activity to make one very nice thing, and it's very easy. But why I have said, because it is in your new chapter, that is symmetry and pattern. I will just say you one thing about symmetry and pattern, and that will be very interesting. So geometry is going to be finished with this topic, that is angle, and next chapter which we are going to move in our symmetry and patterns. Symmetry and patterns. So what you have to do, one more task, take a mirror, take a page, okay, take a very nice page, then take a mirror at the this is say the mirror, you take this mirror at the middle of your page, fine, and this is the mirror I'm just showing you. So this is your mirror, say, and then take a pen and try to draw some patterns like these, whatever. You will see that the same reflection you will see inside of the mirror, and it will create a very nice scenery. So you make your own image, you make your own art, and put the mirror there, and click a photo and send in the group, and let me see how you draw it. You can also try one more thing, that is, if you draw like this, you will see that automatically in the mirror you can see that you have drawn a. So try to draw as many as alphabets you can do. You can see that B you cannot, C you cannot, D you cannot, but some alphabets are there that you can, like A, H. More I will not tell. You have to find out what are the more alphabets that you have to, like that you can draw like this. So this is your basically homework for your next chapter. So bye bye. Try this activity and make that activity which I have sent in your PDF, page number 11. Okay, bye.